limit n tends to infinity, sine pi times root over n square plus 1. So this problem we can also solve like limit n tends to infinity. Since we know that sine n pi minus pi times of root of n square plus 1 can be either negative, positive or negative. So I will write minus 1 whole to the power of n, which is equal to limit n tends to infinity minus 1 whole to the power of n sine of n pi minus pi root over n square plus 1 into n pi rationalization pi times root over n square plus 1 upon n pi plus pi times root over n square plus 1. So which equals to limit n tends to infinity minus 1 whole to the power of n sine times of, this is a n square pi square minus pi square or n square minus, we will be getting pi, we will be getting pi square and divided with n pi plus pi n taken common 1 plus 1 by n square. So which is equal to limit n tends to infinity minus 1 whole to the power of n sine of minus pi square divided by n pi, or if I take n common, pi plus pi times of root over 1 plus 1 upon n square. Since for as n tends to infinity 1 upon tends to 0, so 1 upon sine of 1 upon n will tends to 0, this one, and here also 0. So this is 1 upon n tends to 0, so we can write the answer here as limit n tends to infinity. Let's not write limit n tends to infinity, so we'll write 0. Since n tends to infinity 1 upon n tends to 0 is the reason.